When we talk about joysticks, we have different setups that we could use. For instance, the one that we are going to use right now is the Xbox 360 joystick, which is created by Microsoft. It was initially released in November of 2005. The power source came either from a USB 2.0 cable, or they could have two AA batteries to help out. As you can see from this image, we have 11 different buttons. The first one, which are the most obvious, are the A, B, X, Y buttons on the right. Then we have the back and start buttons and the guide button, which is in the middle. Here we have an indicator to know which number of player we are, or which number of controller we are. And then we have the bumpers, which are at the top of the controller on the left and on the right. The two last buttons are the axes that we have on the left and on the right. You can move them around and you can also click them, and this is why they are considered a button as well. Then we have two triggers, which are on the back of the controller for the left and the right. And an important thing is that the triggers, they are not a boolean. They are not turned on or turned off. Actually, you can move them little by little, so they are considered like an axis in Unity. That's an important part. Why? Because we can go from 0 to 1, having values in between. It's different than the buttons, which are pressed or not pressed. Then we have the two sticks, which have an X and Y axis, where we can select which is the dead point. As you know from these ones, when you release the stick, it will go back to the middle, to the center. Okay, so we can know how much we are moving on X and Y for both of them. And finally, we have the D-pad, which allow us to have four different buttons, which includes up, left, down, and right. And we can use them a combination of those, like up, left, or up, right, or down, left, down, right. Finally, the connectivity of this particular joystick is either using a USB 2.0 cable, as we said before, or it can be wireless. And inside the Xbox, it has the receiver. Now, this is not the only kind of joystick that we have. There are other joysticks available. One of them is HOTAS. So, what do you think HOTAS mean? Well, if it is not that clear, it means hands on throttle and stick. And this is basically designed for anything related to aircrafts. One of the most famous is the Microsoft Simulator games. Another kind would be like Mech Warrior, and there's a lot of different things that we can do. If you look at the one on the left, you will see that these kind of devices actually pack a lot of different axes and buttons. For instance, the ones on the left is a Thrustmaster HOTAS, which includes 6 buttons on the left. Then it has an axis for the throttle in the middle on the back. Then on top of it, it has the axis for the trigger. It has a little joystick, which would be 2 axes for X and Y, and it is a button as well, and it has a button below that. And the whole stick, it is another two-sided axis, which includes X and Y. There are many different kind of devices like this. There's a huge amount of people that love to do the whole simulation thing, especially about airplanes. And this is the target market for games like the Microsoft Simulator games, the Flight Simulator. So you can find joysticks that are really cheap, maybe around 900 pesos, all the way to millions of pesos on devices, which will allow to make you feel like you are on an actual airplane. Okay? A second kind of joystick would be a wheel and a shifter. And this is very common for games related to cars, like the Gran Turismo or the games from Microsoft, which is the Horizon, etc., Forza games. So these kind of simulators, or you can play arcade games like Need for Speed and others, include the wheel, which it only has one axis, which is moving on the z-axis actually. And then we have like buttons. You can see right there 6 buttons on the wheel, and also the paddles, which will be like buttons as well. Then we have the pedals, the shifter, or the clutch, the brake, and the gas pedals, which would be like an axis, each one of those, going from 0 to 1. And then we have the shifter, which will be like similar to a button every time that we hit one of the different gears. And you can see that it also includes a D-pad, and it has another 8 different buttons on there. Okay. Then on the far right, we have the final kind, which would be something like an arcade or the regular joysticks that you see to play on Xbox, Nintendo, etc., which includes again buttons and axes. And that's the main thing. So in Unity, you can configure any of these devices as long as you have the drivers for the operating system that you are going to use. Great. Okay, so today we are going to connect a joystick to use it on Unity. So the first thing is that we need to notice what kind of connection does our joystick use. So right now, as you can see, that this one is a black one. That means that it can be used for USB 2.0 or USB 3.0. So depending on your configuration, you may notice that you have different kind of ports right here, and some of them say SS. That means super speed. That means these are 3.0 or 3.1 USBs. So we want to reserve these slots specifically for devices that require that, like a hard drive disk, which is a solid state, or a VR headset or other kind of devices. So right now you can see that this one is blue because this is a hub for the monitor that allows to use 3.0, and I can connect my joystick to the 2.0 that I have right here. It doesn't affect it or anything. So once I connect it, you can see that it's blinking and it should appear on the number 1. If you're using Windows, it will do it automatically. If you're using a Mac, you might need to download some drivers to make it work. Today's lesson is going to be about how to use a joystick into Unity. There are two main ways to do it. One is a regular one using the input manager that Unity has provided since the beginning of all time. The second one is a new package that we will not talk today about that. Okay? So the first thing that we need to notice is where we have everything that we require to make it work. So if we go into Edit, you can see that we have different things like the project settings, preferences, among others. We go into preferences, you can see that we have the general and everything else. What we want is actually the input. So if we go into project settings, you will find input manager. And as you can see, it says this is where you can configure the controls to use with the Unity Engine.input API. Consider using the new input system package instead. Okay, so this is exactly what I just told you. So it's important that you know that we can use this one because the new input manager works in Unity 2019.1 and upwards, not downwards. So if you want to build a game or a system or whatever for an old version of Windows or using a license that you have of Unity that is before 2019.1, you are not going to have access to the new input system package. So you are going to have to use the input manager that we have right here. Okay? So now you can see that it says axis. And we have 18 already defined. We have the horizontal. You can see that it has a name. We can use a descriptive name. The descriptive negative name, that means what's the opposite of what we are going to do. What is the negative button and what is the positive button. In this case, since this is horizontal, left and right are negative and positive. And then we have the alternative negative button, which is going to be A, and the alternative positive button, which is going to be D. Then it says gravity. And as you can see, it says it's the speed that the output value falls towards neutral when the device is at rest. That means that when we move the joystick and we release it, how much time it takes to go back into the middle. Okay? Now, as you know, whenever you use a joystick, it begins to have some kind of deterioration. And some joysticks are starting to tilt a little bit to one side or upwards and backwards. So that's why we have the dead value. The dead value is the one that is going to tell us which is the dead zone. So we have an error margin of 0.001. Okay, if we increase that, that means that we need to move more the joystick. This is basically in case that your user is using an old joystick or a very weird up joystick, and whenever they release the joystick, if we don't have a good dead value, the player is going to keep moving. We don't want that. Okay, one of the most important things on human computer interaction is to actually translate what the user wants into the actual things that we do on the computer. Okay? Then we have the sensitivity. This value allows us to know how many units per second we are going to move. Okay? If we change the sensitivity, if we just move a little bit the joystick, we are going to move a lot. If we reduce the sensitivity, the user is going to have to move a lot the joystick. One good example on this is, for instance, if you have a puzzle game and you have your character and you're moving around and you get into a puzzle, when the puzzle zooms in, you want to be really careful on how you move things. So you want to decrease the sensitivity so the user has a broader range of movement to actually put everything together. Okay? Then we have the snap. The snap is what happens when we jump to neutral. Okay? So when we release the joystick, some joysticks stay there. For instance, an airplane joystick, when you move the throttle forward or backwards, it stays right there. It doesn't snap back. So in this case, we are going to use the Xbox 360 joystick that I showed you before. The two joysticks that we have right there snap back into the center. Okay? Then we have the invert selection. Usually, many video games allow you to set up this one, enable or disable. And then we have the type. We can select one of three. If we want to set up a key or a mouse button, as you know, we have other ways to get that information from the input manager. We can have the mouse movement, or we can have a joystick axis. Okay? And then it asks for what kind of axis it is and the joystick number that is going to use it. Okay? So I'm going to create, for now, a new one. So I change it to 19, and I'm going to call this one demo. Okay? It's not going to have any information on this, and I'm going to reduce this. Now you can see that the gravity has increased a lot and the sensitivity has increased a lot. We can play with these values a little bit further. So I will change this to joystick axis, and then you can see that we have 28 different axes that we can use. You might be wondering, why do we have so many? Well, the thing is, as I said before, there are very different kinds of joysticks. One of the most common ones is a joystick for an airplane. If you are a fan of Microsoft Flight Simulator, you might know that there are a lot of different pieces that you can buy, and there's actually people that spend hundreds and thousands of dollars on setting up an environment as close to reality as possible. So these kind of people are the ones that have different devices set up, and one of those devices can have up to 28 different axes. Okay, it is rare, but it may happen. Okay, uh, for instance, a joystick like the one from the Xbox could have 4 different axes depending on how it moves. Okay, or a PlayStation, a DualShock controller, if it is using the 6-axis controller, it has 6 axes as it says. Okay, and then we have the get motion. Okay, we can select to get the motion from all joysticks. For instance, one button that will use that will be the start button. Okay, if we want anyone to be able to select start, we can select get motion from all joysticks. But if we want to set up different people playing around, Unity supports up to 16 different joysticks connected at the same time on a single computer. If you want to have more joysticks, you can do it, but you need to use a different. Maybe if you connect on a network, you can have more joysticks. Okay, so for now, I'll leave it at get motion from all joysticks. Okay, I will put this one right here so we have it available. And now I will create a very easy scenario so we can start testing up what we are going to do. So let me put this on 0. And I want to create a platform which is big enough to support what we want. Okay, and I'm going to reduce the size of the platform. And I'm going to introduce a little sphere. So I will put it on 0.1. And you can see that we have our sphere right here. First thing that you might be wondering, why does it look a little bit like beige or gold? This is because the light has not been rendered. So right below on the right, we have the auto generate lighting. So I will enable it for now. And you can see that now everything looks white, which is going to make it really hard for us to see where our ball is. So I'm going to create a material for a ball, and it's going to be a simple material so we can easily see where our ball is. I'm going to make it a little bit reflective. And there we go, we can see our sphere correct. Okay, I'm going to add physics so we can start working on it. And to do that, I will include a rigid body. That means that when I hit play, it will fall down and it will be right there. So let me remove maximize and play so we can see it from the scene. Oh, this is because the game screen is right here. So usually put this one right here so it doesn't switch between one and the other. Okay, and you can see that our ball is right there. So let's introduce some controls for our ball. Okay, so I'm going to add a new script and I'm going to call it the ball controller. Okay, I think that's good. Okay, so if we want to move around, we will usually use something like input, get, key, and from there we will be working to get the information. Okay, So right now what we are going to use is actually get axis, okay? And right now we have the horizontal axis, and you can see that this is actually a string. So we can put it on a variable so we do not hard code this. Now, since I'm using the rigid body, I want to get that rigid body to control it. So I'm going to add a variable, which is going to be the rigid body. Now, some of you might be wondering why the autocomplete is not working. So usually what we need to do is if we go into the preferences, you can see that we have the external tools and we can regenerate the project files. Okay? Once we regenerate the project files, we can go back, double click on it, and Visual Code should be now able to load everything up correctly. Okay, so let's see. Everybody equals, no, not yet. Okay, let me close it to ball. Okay, yeah. That issue that is appearing is because getAxis give us a float. So depending on what we get right here is how we are going to move. Okay, so we want to use the rigid body for that. So we will have the rigid body, and then now you can see that we have all the information from that. I just had to close and open up the Visual Code a couple times. Okay, so we can have a torque. Okay, and with a torque, we can have where we want to move. So I could say that we want to move forwards. Okay, multiply by what we have on the horizontal. Okay, and we can select which kind of forward move we want to have. So in this case, I will say acceleration. Okay, and we will see what happens with this. Okay, it's compiling right below. Everything seems to be okay. I will include this code into our sphere. And now I will hit play. Now, since it says horizontal, that means that I can click on the keyboard to the left, and you can see it moving, or to the right, and you can see it moving to the other way around. Now, you also remember that they had A and that they had D. Okay? And if I grab my joystick and move to the right, it moves right there. And if I move to the left, it moves right there. Okay? Now, it is moving really slow. And we have a couple of issues. First issue, we are moving the rigid body. So please remember, that kind of thing should be on the fixed update. Why? Because the physics are calculated on the fixed update. The second thing, this should be multiplied by time dot delta, fixed delta time actually. Okay, oops, I put it inside the parentheses right there. And now it means that I can also include public variable to select the speed that we want. Okay, so I will include for now a speed of 100, and let's multiply by that speed. And we could also get the axis from a string. And we put the defaults. So now I do not have this hard coded, and this is better codes. Okay, we go back. Now we will see the options right here. It has the default information that I put right there. And I can move left and I can move right. Now, if I change this to the one that we created, which is right here, it says demo, and I hit A, you will see that nothing is happening, but it is moving. So I need to hit to the other way around. So I'm moving my joystick to the right to try to slow it down. And I will release it. Now it is being released, but as you can see, it is moving a little bit to the left. If we go back into the settings, you can see that the gravity and the sensitivity are incredibly high. Okay? Look how depth was 0.001 and sensitivity and gravity was 3. We keep the same depth, but we have a different value for gravity and for sensitivity. Okay? So we have this information for the x-axis. And we have also vertical. Okay? So we can select, I will run this again. I will increase the speed. And one important thing is that if we have the rigid body, we can change the maximum values. You can see right here the max angular velocity. Okay? So we can set the max angular velocity to a very high value. So I will put an enormous value for now. And okay, this is deprecated now. So it says that I have to use max angular velocity. I'll go back. So we should be 10 times faster on acceleration. And you can clearly see how that is working. And we can easily include, this is the horizontal axis, and I can create a vertical axis. I have right here the horizontal axis, and I can simply include right here, instead of forward, I can put right and use the vertical axis. I can simplify this code if I want. For now, let's just make it work. You can see it says horizontal and it says vertical. So if we go left, right, forward, backward, and we can be moving around. Now, the thing with the rigid body is that currently we are using the information locally. So that's moving a little bit weird. Okay? So this is basically how we can get this information for the axis. If we want to get information of a button, we can use if input get button. Right here you can see. And we can have also get joystick names. So if I get button, and I can look for a specific button. Okay? So this is how I can check if that button was selected, or I can use the get key down, for instance, and the key codes, I can go all the way to joystick, and I can check which one is being used. Right now, I only have one joystick connected, so if I check which button is the joystick button 4, for instance, I can put an explosion force, right, explosion force, I will hard code it for now. Let's say 5,000. The position will be our position. So I will use the transform position. So I have to put it a little bit below so I can have or plus vector 3 down, whatever you feel that it's better. The radius that I want to affect, let's say an F, and right there, this one should be enough. And if we go right back, so if I start clicking on the joystick, I found that the LB button is the one that activates explosion force, which has an R ball floating all the way to space. So let's go back into the cube, and you can see how, since it was too fast, it just went through the cube. So if I just reduce this maybe to 50, it's easier to see. You can see with LB how the ball is jumping, okay? So if I move, I can be jumping around, okay? So you have all these different kinds of ways to get into the key code. You can actually, since key code is an enumeration, you can use this enumeration and go through all of them to see which button you're actually pressing right now. Just inside a 4, you can go to all the enumerations. You can convert enumerations back into something loopable, and that's how you can get them. So for instance, if we go into enum, oops, sorry, system.enum, you can see that right here we can get the values for all of this, okay, or names, etc., etc. So you can try that inside a 4 and check whenever you use a new controller how to set it up, okay? So that's basically how to use a joystick. It is really important to make sure that you test any kind of new joystick that you're going to support to make sure that the sensitivity, the depth value, and the snap are working correct. Okay? And that's it for this video. Finally, we need to put everything back into place. So the best way to do that is to put the remote, and then we grab the table, and we can just follow the actual pattern that it already has. Okay, so we need to make sure that it fits correctly and it is smack right here. So we just make sure to put everything side forward. Okay, nothing is out of place. And finally, we put the lid on. Okay, and that's it.